Hello, my name is Margaret O'Brien. I'm a data specialist at UC Santa Barbara, and I work with data repositories and ecosystem-level research projects like the LTER network. I'm also part of the data management team for the Santa Barbara Channel Marine Pond. Today, I will tell you a little bit about EML. I'll outline a few essential features and then give you some examples of how these are used for data related to organisms. EML is an XML specification for scientific metadata that describes tables and other data objects. It was written by data managers and scientists and was in use in 2003. EML is frequently used for ecosystem-level research programs because it can describe most of the data types we see, and choosing EML reduces the number of specs data managers work with. The basic granule is a data package composed of the EML metadata file plus its data objects, with the majority of those being ASCII tables. Third, EML has very detailed table-level fields, detailed enough for accurate machine reading of the values. For example, relational database DDL can be created from the EML metadata alone, including column typing, bounds, value domains and ranges, and key constraints. That combination of granular metadata and metadata readability, machine readability, means that tables can be easily reused. We also can generate code from that table-level metadata to ingest tables into most analysis systems like R, MATLAB, and SAS. And EML metadata can also be used to ingest tables directly into ERDDAP. And lastly, EML supports annotation with external dictionaries. This is specifically designed to support ontologies with exposure via RDF. This is a data package of a typical community survey. It comes from an LTR site studying the coral reefs of French Polynesia. As data managers, probably our most important objective is that our data packages are coherent. A data package should be well planned, fully described, and sensible, with all of its parts fitting well together. This is particularly important for data from primary ecological research because there are often sampling decisions that determine how data can be used in the future. A detailed spec like EML supports that objective. There are a few features to point out. First, that this is an ongoing collection with additions made approximately yearly. For ongoing packages like this, EML can handle identifiers with revisions with no problem. This package includes both a long style and a pivoted wide table to make reuse simpler. EML can handle either or both. And on the right is the XML to describe data columns, and you see the detailed fields of one column. Below that, you see the primary key constraints for the entire table. You would use these to translate to DDL or for checking for duplicate entries. Then on the left is the data table level metadata, which contains the physical descriptions. Some of these features can be inferred, but having it explicitly laid out is safer. Data coming into any system should be checked for a certain level of integrity before being admitted. Repositories run sets of checks on every incoming data package, and detailed metadata makes that relatively easy. These kinds of checks can be categorized or mapped to principles like FAIR. I mentioned earlier that the code for ingesting into analysis platforms can be created automatically. And here at the bottom on the right, there's an example of that, and it's how it's delivered by the repository's web service. I want to briefly describe here a mechanism for converting primary data sets to specific formats like the one required for GBIF and OPUS. We use a workflow framework to harmonize primary data sets for this kind of use. On the left, you see every data set has its canonical version. This is the fully described, coherent package managed by the people who know it best. But in this context, it becomes essentially raw data. A harmonized intermediate in the center can be managed by the repository. Now, these are not intended to be canonical, but by converging on a single format, the original data becomes much easier to use. And the process of harmonizing gives the raw data provider feedback about what features are the most important. The third step is the production of data sets for particular uses. This could be a synthetic analysis or the Darwin Core Archive format used by OPUS for easy querying. And this is the result of that. This data package is a Darwin Core archive, but we also use the full EML to include attribute level descriptions for that data table. Having the complete EML means that the data set can be understood both within the OBIS context and on its own. A data set in the GBIF system, or OBIS, would have only the one-line header of the CSV with its Darwin Core term, and it would be up to the user to do the research to understand that more fully. This package could be contributed to GBIF as is. GBIF simply ignores the parts that it doesn't recognize. In 2016, using the data packages from an LTER site, NOAA developed the code to directly ingest EML-described tables to any ERDDAP system. And since then, data from our MBON in the Santa Barbara channel have been imported directly to the repository, from the repository to the ERDDAP maintained by SCOOS. And there's been a lot of focus lately on defining essential biodiversity variables. EBVs characterize critical aspects of an ecosystem and are intended to function as an interface between the raw data and biodiversity indicators. To connect raw data to a system of EBVs, we need to be able to annotate that raw data, and EML is set up for that. Here is one example of an annotation that references an external vocabulary for measurements. This annotation URI asserts that this column measures a type of population abundance, which is an EBV class. An application then can access the complete description of that concept from its URI, and EML supports annotations in other places as well. I want to pause here to mention that an ESIP session next week will draft guidelines for selecting vocabularies. This is not targeted specifically toward EML or toward domains which produce biological data. The ability to choose and trust a vocabulary is a much broader need. So that covers the basics of what you can do with EML. Here are the resources I talked about, including the data packages and the examples. The takeaway message here is that there's a big gap between the choice to adopt a spec for metadata and the choice and the goal of data that are fully understandable and reusable. We are still shrinking that gap, mainly by highlighting what works well for the needs of both researchers and data managers. The EML spec has been up to the challenge, and there is a responsive and interested community to advise. Thank you.